All right. My key is this. Remember, when we subtract these, there's a rule. Remember? Log A minus log B is equal to log A divided by B. So, we just put this over that, or this under that. That's it. Log base 5 of x minus 2 divided by x equals 1. Then we have another rule. We go log base of a number is equal to the exponent. Okay? And then we have the base raised to the exponent is equal to the number. That's it. So we're going to change this from log to base form. Okay, am I recording?
I think so.
Yeah.
It says far. Cool. Alright, so I'm going to take this base, put it right there. I'm going to take this number, and I'm going to put it out there. And I'm going to take the exponent, and I'm going to put it right there. So 5 to the first power, which just means 5, is equal to this. And now it's algebra. Multiply both sides by x. So I get 5x is equal to x minus 2. Move your x. Minus x minus x. I get 4x equals minus 2. Divide by 4. I get x is equal to negative 1/2. Okay? That's the hardest log that we have. They don't get much harder than that. Sometimes going the other direction, we give you these ones and then you got to put them back into a log where it's, the exponential ones. But that's it. Alright, so this log, we got to think this is equal to x. So it's 2 to the x is equal to 16. How many 2's need to multiply to get 16? 4, right? That means 4 equals x. Or this equals 4. Okay? That's it. You're evaluating it. Okay? Now you could throw it in your calculator as log of 16 divided by log of 2. That also works. Okay? Because that's a rule, right? Log of A with the base is log A over log B. Okay? Then we've got this. They want us to expand it. Okay? So, I have to remember that this rule is that power rule. Log of x to the A is equal to is equal to A log of x. I just put it out in front. Okay? So that's going to go out in front. That's it. 2 times the log base 7 of xy cubed. Now, remember the other rule? Instead of minus, we do a plus. Log A plus log B equals log AB. So, put them together. Log AB, pull them apart. 2 times the log, the quantity, because this is in its own thing, right? So the quantity of log x plus log y to the 7th base. Okay? And then we take this guy and move it out front. 2 times the log base 7 of x plus 3 times the log base 7 of y. That's it. That's it. Expanding. That's logs. Okay? Alright. Next. I gotta change this to degree. I mean, if I understand these, that means it's saying, hey, 4 pi over 4, and this is 0, right? That means that there's going to be 4 of these. Well, right now there's 2. So I could go, boom, that would be 4. 1, 2, 3, 4, right? So how much would one of these be? If I cut 90 in half, how much is that? 45. It's that simple. Oh, that's it, right? Now, there's another way you can do it. It's pi over 4 times 180 over pi. Okay? So, what goes into top and bottom? I can take out a pi. I can take out a 4. Right? 4 goes into 18 how many times? 4 times with 2 left over. 4 goes into 20, 5 times. Done. So 2 ways to do it. It's really, really basic. This is going the other way. They want us, don't they want us to turn this into, or they want us to graph it. What do they want us to do? Convert to radians. Okay? So they want us to convert this to radians. This one, we're going to do the opposite of this. Right? So we want to put pi over 180 in this case. Because I could think of this as 570. What is that? 360. What's it? 360 plus 180 is 540. Is that right? Yeah, 540. So think of 540 from 570. That leaves how much? 30. Okay? So that means this is going to go around negatively. If I want to think about it like we did here, negatively 360 times, right? Plus another 180, plus another 30, right? Okay? So if I think about that, how many of these pieces are there with the 30? So how many times is 30 going to 90? 3? So that means there would be 6 altogether. So this would be 6 pi over 6, right? For 1 pi. So if we think about that, we're going around 6, 12, 18, 19. Over 6. Negatively. But let's just make sure by doing this math. Negative 570. I'm getting so comfortable with this radian stuff now. I never was this way with you guys. But teaching it this year and teaching it with these ratios, I'm getting very comfortable with it. If this works, I mean, that's, for me, I'm surprised. Right? I obviously understand radians for the first time in my life, and I've been not really teaching radians for 20 years, but I've been teaching 20 years. You know. So, looking at these radians in a whole new light this year. I'm always trying to make things easier. But, okay, digress. What goes into these? I know 10 does, right? So that just brings me down to 57 pi over 18, right? And then, what goes into 57? Well, 5 and 7 is 12, so I know 3 does, right? So 3 goes into 5 once, with 2 left over, and 3 goes into 27 9 times, right? And 3 goes into here 6 times. Holy cats, there it is. Okay? So this is another way of thinking about radians. You could do this. This is simple math. But you can actually know it by thinking about how many of those pieces there are. Because radians are always fractions. It doesn't matter if there's 5 pieces, 8 pieces, 12 pieces, 6 pieces. It's always a fraction of a whole. And once you understand that about radians, radians become a lot easier. Did that help? Did that clear some things up for hopefully someone? Maybe? All right.